All right, how are you guys doing today? Woo, all right. How many of you guys are actually developers and not ops people? Okay, so about half. How many of you guys have worked with or currently work with single page applications? Okay, so about most of you. And how many of you guys have heard of or currently work with JSON Web Tokens? Okay, so all of the SPA people. So my talk today is titled "A Token Walks into a SPA," and it was a catchy title that got me accepted. But really, it's a talk about JSON Web Tokens and how we can secure single-page applications that live entirely in the browser. And for you ops folks, we're going to have a portion for you as well, where I'm sure people are coming to you, the developers, and they're saying, oh, I want to deploy a new Angular app, and I want to change entire infrastructure, and hopefully you'll get a bit of an understanding of why people want to build single-page applications. So with that said, let's get started. So just a bit about me. My name is Kukic, and I work as a developer evangelist for a company called Auth0. How many of you guys have heard about Auth0? Okay, woo, that's awesome. So for those of you guys that haven't, we are an identity as a service startup company. And basically what we do is we handle all of the authentication and authorization use cases for a lot of companies, both small and large, so that they don't have to build login systems, login forms, single sign-on, and all of that fun stuff. And with that said, let's get into single-page application security best practices. And really, how do you secure an application that lives entirely in the browser, where anybody can download it, anybody can look at what's in there? And the simple answer is you really can't, right? So, we can end the talk right there. But when it really comes down to it, when it comes to single-page applications and applications that live in the browser, we're not so much concerned with securing the data within that application. We're concerned with authorizing users to get private data, get secure data from a backend service in a secure manner where attackers aren't going to be able to just call our API directly and get that data. So we're going to be focusing more on the authorization use cases when it comes to single-page apps. So before we get into that, though, let's talk about a scenario that most people are typically aware of, or anybody that's written an application in the last 20 years is going to be pretty familiar with. So here on the screen, I have a green block and a blue block. And the green block is our secure infrastructure that all of our lovely ops people maintain, manage, and secure, make sure all the patches are up to date, and this is our secure sandbox. And within that secure sandbox, we have our application. And here I'm going to use Pied Piper as an example, just because Silicon Valley came back and it's topical. So within these confines, our application that we developers build is supposedly fully secure, and we're in full control of everything. And then we have those pesky users coming from the World Wide Web via HTTP, via different services connected, and they make requests to our applications, and we have full control in how we validate their requests. So in a traditional sense, when a user comes to the application, our server is going to look at that request, make sure that it can process that request, it could serve it. So if the user were to go to piedpiper.com, like the homepage, for example, you don't need to be logged in, you don't need to be authenticated. So we would just render that view, that user interface for the user, and send it back. So in this scenario, our infrastructure is in full control of basically everything, the entire stack. So from the request going in, to it being processed, to the page being rendered server-side, to it finally being sent over the wire to the user's browser. And then if this is an authenticated use case, we can validate the user's identity. We can look at that session ID, get that session cookie, make sure it still exists in our database, and then serve the protected resource. But typically, we don't want to build applications these days anymore, because as Chris said in her talk, that this is a monolithic application. It has two components, maybe even three. For example, the service and the user interface combined together. the way we build applications these days is our secure green infrastructure has become much, much smaller. So now we still have a secured infrastructure, but it's much smaller, and we're not so much concerned with the user interface anymore. We've kind of let all of these other great frameworks, all of these other great technologies take care of our user interface. So, whether you're building Vue applications, Angular applications, React applications, you roll your own single-page application framework, or you might be still on jQuery and try to make it work. Your front end is totally decoupled from your back end. And typically these days when we build applications, we don't only build for this one app.pipepiper domain anymore. We're thinking we might need a mobile application down the line, or we might want to build an IoT device. We might want to be able to call pipepiper from our Google Home or Amazon Echo device. And instead of building separate backend, separate infrastructures for each of these dummy front-end clients, we just want a simple way for all of our unsafe, potentially unsafe clients to talk to our fully safe infrastructure backend. And we want that infrastructure backend to talk the same language, coming in and out to all of these different clients. So how do we do this in a secure manner where we don't fully expose our API.pipepiper domain, our server, to the world for anybody to easily and freely consume? And the answer to that question is JSON Web Tokens, JWTs, or JOTs. I'm going to use that term interchangeably, but they basically mean the same thing. And for those of you guys that don't know what these JSON Web Tokens are, or why developers keep talking about them, let's look at a very brief and confusing definition. So per the RFC 7519 standard, JWTs are an open industry standard method for representing claims securely between two parties. And this doesn't really tell you all that much. If you haven't worked with them, you just read this definition, you might be more confused than just seeing the name. So let's make it even more confusing by looking at a JSON Web Token. So right now, the JSON Web Token, it has different colors. In the real world, they don't, but just to separate it, I've split it into different parts. And, to most people, this is just a bunch of characters. They don't really mean anything. And even to most machines, they don't mean anything. But they actually play a very important role in the way that we handle client, private communications between a public client and a secure backend server. And to kind of show you an analogy of how these JSON Web Tokens work in the real world, because I could talk about all of the technical details of them, but if you haven't worked with them before, that's just going to cause more confusion. So what I wanted to do was show you how JSON Web Tokens or how token-based authentication systems might work in the real world. And I spent a few days thinking about what's a scenario that most people are familiar with, and I came up with driver's licenses. And so what I want to answer is how is a driver's license like a JSON Web Token, and I want to see if this analogy works. So let's look at how we can compare a driver's license to the different components of a JSON Web Token. And a typical JSON Web Token always starts, it has three parts, and its first part is always the header. So let's put our driver's license on the left-hand side and our JSON Web Token on the right-hand side. And let's figure out what the header for the driver's license is. Well, its header is the fact that it is a driver's license. It says that, hey, I'm a driver's license on it. And we can see that this particular driver's license was issued by the state of New York. So for, that pretty much tells you all you need to know about a driver's license, that you're working with a driver's license. When we look at our JSON Web Token, the header is this part in green. And I don't know if you guys can see that very well, but basically this, clicker's not working. But basically the first part in green up to the first period. And this header is basically just a base64 URL encoded string. So if we were to decode this string, this is the the content that would be held within it. And it's really just a JSON object that has two properties, an algorithm and a type. And we'll get into the algorithm in just a little bit. In this case, we're using HS256. And the other property, type, it just tells us that, hey, you're looking at a JSON Web Token. So far, so good. I think our analogy still works. Let's look at the second part of a JSON Web Token, which is its payload. Now, the payload of the JSON Web Token is potentially its most important part. It's the information, it's the claims data that you want to transmit between your front-end client that's in the public that anybody can see and your backend server. So let's put our driver's license and our JSON Web Token side by side again. And let's look at the payload for the driver's license. We have the driver's license holder's picture, we have their name, their address, their demographics, such as their sex, height, weight, eye color, and then we have a list of restrictions. So they can drive cars and light trucks, but they can't drive trailers and bigger vehicles and all kinds of that stuff. With our JSON Web Token, it kind of works the same way. Again, it's just a base64 URL encoded string that we can easily decode and figure out what's in it. And as you might expect, it's another JSON object that has a couple of different properties in it. And right here, we have 4 properties, sub, which stands for subject, the user's given name, their family name, and an admin property. In this case, we set it to true. And this is basically the data that's going to be transmitted over the wire to our backend server for validation once this token is decoded by the server. And when it comes to these claims, there are really 3 different types of claims we can put in a token. And some of these are defined by the JSON Web Token standard. So these are what they're referred to as reserved claims. And there's only a small number of those, maybe like 10 or 12. And those are claims like the sub claim, which is the subject claim, which is basically the user ID. There's also the ISS claim, which stands for the issuer. So who created this JSON Web Token? Do you trust this? Do you trust this entity that's signing this token? Or issuing it. And then there's also claims like the expiration time of the token. So when does this token become invalid? The issued at time, when was this token created? So all information relating to the creation of the token that you can use to verify the authenticity of. And then there are what is referred to as public claims. And public claims are mainly, they're defined with they're registered with the IANA. And these claims are usually, mostly registered with the OpenID Connect, series of RFCs and standards. And these are really for API interoperability. So if you're using JSON Web Tokens, you're more than likely using them for, to manage identity. And with that comes, transferring user identities across different applications, across different platforms, across different providers. So, there's a set of maybe 50, 60 different claim properties that kind of help you interoperate your API with other APIs. And that might be, instead of saying first name, you say given name. And instead of saying last name, you use the family name attribute. So this just makes it easier for your API to interact with different, third-party APIs. And then finally, when it comes to the payload, are the private claims. And these claims are only relevant to your specific application and to your business domain. And these claims can be anything you want them to be. You can call them whatever you want. You can put whatever valid JSON data in there you want. So in my example here, the admin property would be a private claim. And I chose to represent it as like a Boolean true or false property. But I could have done like a numeric 0, 1. I could have done a string. I could have, instead of having the admin property, I could have said, here's a list of permissions and passed in an array of, you can view users, you can delete users, you can, do all sorts of things. So it really depends on your use case and how you want to represent the users in your application. So, and then before moving on, what I wanted to point out was that the header and the payload of the JSON Web Token are base64 URL encoded. These are not encrypted. These are not, protected. So anybody that has access to a JSON Web Token that, can read your JSON Web Token can easily read the data in it. So if you are using JSON Web Tokens or thinking about using JSON Web Tokens, please don't ever put any sensitive data in there, like social security numbers, credit card numbers, anything that you wouldn't want public, you don't want to put within the JSON Web Token. And with that said, let's get to the signature and the security aspect of a JSON Web Token. So we'll put our driver's license up and our JSON Web Token, and for the signature, for the security aspect of our driver's license, typically what you see is like an ultraviolet light hologram that's embedded within the driver's license. And it could be like another barcode, it could be a magnetic chip that's added into the driver's license that just helps trusted parties validate that this driver's license was issued, by your state's DMV and that it is a legitimate driver's license. When it comes to our JSON Web Token, the way that we ensure the integrity of the token, the way that we can kind of vouch for the token is by cryptographically signing it. And in my scenario here, we signed the header that the signing algorithm we used was HS256. And here's how we would basically get that signature, that last part of the token. We basically run a cryptographic hashing algorithm, in this case, HMAC SHA-256. We take the header of the JSON Web Token, combine it with the payload, and then we pass in the case of HMAC SHA-256, we pass a string-based password. So in this case, the password is Loki sucks. So once we run it through this algorithm, we're going to get that signature at the bottom, the last part of the token, and that's what's going to ensure the integrity of the token. So once we have this token now, we can send it to our backend API, and our backend API is going to look at this token and say, hey, was this token signed with the password Loki sucks? And if it was, then we can kind of, we can understand and we can know that this token was signed either by us or by a trusted party that we entrusted with signing the tokens for us. So that's the HS256 algorithm, or the HMAC SHA. There's also like the RS SHA-256, which is a public-private key pair. So you sign the token with a private key, and then you issue public keys that can decode the token on your behalf, which is a little bit more secure than just using a string-based password. But we'll get to that in a little bit. So do you guys think the analogy of a driver's license to a JSON Web Token kind of still stands? OK, sweet. So now let's see how we would use these tokens in the real world. So let's start with our driver's license. Say Thor comes down, from Asgard, and he just went and saw the new Avengers, and he wants to go out, get a beer, or go out with the Avengers to celebrate, making another $1 billion. So the responsible thing for Thor to do would be to go to the DMV, fill out a bunch of information, wait God knows how long, and get a legitimate driver's license issued with it for him that has the correct UV light hologram. It has, it is issued by him. They validated his identity. And now Thor would be ready to go to the bar, to the club, and he can use this token. So he'll get to the front. The security guard will say, hey, I need to see your ID. Thor will, since he has the driver's license, he'll present it. The security guard is going to validate it. He might run it through one of those little machines that tells you if it's a fake ID or not. And since he did get a legitimate ID, the bartender's going to, or the security guard is going to say, great, you can go in. And once Thor is inside the bar, he's going to go, talk to the bartender and order a drink. The bartender, again, is going to ask him for his driver's license so the bartender can verify his identity and make sure that he has the authorization to actually purchase a beer or purchase whatever drink he's trying to get. Since his ID is still valid, he's going to be able to buy that drink. But knowing Thor, he doesn't strike me as the kind of guy that would go and wait 6 hours at the DMV to get a driver's license. So instead, he might go to, say, this shady character in red, and instead of validating his identity, he might just give him some money and say, hey, can you give me a fake-looking driver's license that's going to get me into a bar? And the shady guy is, of course, going to take his money, give him a fake token, a fake driver's license. And now when Thor goes to the bar, presents his driver's license, and the security guard out front goes to validate it, he's going to right away see that this driver's license isn't valid. It has falsified data. It doesn't have the right hologram on it. And he's going to tell Thor to hit the road because he doesn't have a valid token. So that's how we use, quote unquote token-based authentication in the real world. Now let's see how we would apply it in the digital world with JSON Web Tokens. So again, we have our secure infrastructure in green and our front-end client in blue, which is fully public. And say the user comes to our application, and the first thing they want to do is get a list of their orders. So at this point, they're not authenticated. We don't know who they are, but they click the orders page, and we make a request to our backend to the version 1 orders endpoint, and we made this request, but the server is going to right away look at the request and ask, hey, do you have a valid JSON Web Token? And in this case, you don't even have a token, so the server right away is going to deny you, send you a 401, and say, hey, you can't do this. I don't know who you are. It might redirect them to a login page, but basically, they're not going to be able to get a list of orders because we don't know whose orders we're trying to serve. So the next thing the users are going to do is they're going to hit the authentication endpoint, and they're going to provide their set of credentials. So they're going to log in via username and password or a social connection. However they do it, they're going to log into the system. And once our backend server, once our secure infrastructure can validate the identity of that user, it's going to issue a JSON Web Token to the front-end client. And since the JSON Web Token standard, they didn't really design a logo, I just used the open for business emoji. So we'll keep using that for the rest of the talk. So basically, now the user's authenticated. They have a JSON Web Token on the front end. They're ready to hit the orders endpoint again. So let's see that. But now when they go and try to get a list of their orders, their front-end application, and again, whether it's a React application, a Vue application, is going to send the JSON Web Token that was that the server returned previously with this request. So now the server is going to look at this incoming request. It's going to see that it does have a JSON Web Token, but the server is paranoid, so it's also going to validate that this JSON Web Token has all of the correct data that it expects, that the token's not expired, that it was issued by this specific server. And if and only if all of those scenarios match up perfectly and everything is okayed, then will the server return the JSON response that has the list of orders that the user placed. And now our Vue application or our Angular application can go ahead, take that JSON data, and present it to the user in the pretty UI. Now, that's how you would typically do it. But the good thing about JSON Web Tokens is your server application, your specific API that manages, your orders, your, whether it's your orders, your returns, your inventory, doesn't have to be the server to issue JSON Web Tokens. You can kind of simplify this and take your identity and have somebody else manage it for you, or you could just have, your own authentication server as a microservice that is only concerned with the user's identities. So let's see what that scenario looks like. So we have now this three-pronged approach where we have our existing backend API and our front-end client. And now we have an authorization server. And in this case, I'm just going to use Auth0, but it doesn't have to be Auth0. It doesn't even have to be a third-party service. Again, it could be a microservice that you develop that you only want to handle user identities. So what's going to happen in this scenario is the user is going to come right in the middle here into their Vue.js application, and they're going to say, hey, I want to see my list of orders. But before they do that, the first thing they're going to do is log in. And they're going to log in via this third party or via this microservice that handles the user authentication. And once they're authenticated there, that service, that microservice, is going to be tasked with issuing the JSON Web Token for our front-end application. And now our front-end application has a valid JSON Web Token, but so far our secure infrastructure that serves orders and inventory and all that stuff isn't even involved. It doesn't even know that this transaction happened. It's not concerned with it. But when the user goes and says, hey, I would like to see my list of orders, it's going to send the JSON Web Token that it returned, that it got from the authorization service. And now our infrastructure is going to look at that token, validate it, ensure that it came from this specific, say, Auth0 service. It's correct, it has the right issuer, it's not expired, it's a valid token, and then it's going to return this, return the order data so that our front-end application can render it properly. Now, so this is the kind of fairly typical, fairly modern way to build applications. And the question that I most get is, where do we store these JSON Web Tokens? How do we persist them? Because right now, if you just got this JSON Web Token and you didn't store it anywhere, you didn't persist it anywhere, when a user refreshes your application or they open it up in a new tab, they're going to be logged out because that JSON Web Token is what drives whether they're logged in or not on the front end. And typically, if you Google JSON Web Tokens and you try to figure out, where do I store these tokens, the general consensus you're going to get is store these guys in local storage or put them in cookie storage, put them in session storage, and you'll be good. And I'm here to tell you that that is an anti-practice, and you should not do that. But you also don't want to have the crappy user experience of having the user log in every single time that they refresh your application, because that's a crappy user experience, and you're going to get a whole bunch of support tickets and a whole bunch of angry customers. So how are we going to do this? Basically, what do we do now? Well, the answer is, let's bring up our application without any of those arrows. So the solution is, when your user goes to your authorization server to authenticate, once they're authenticated on the authentication server, you're going to store a cookie on that login.piedpiper domain or accounts.piedpiper.com domain, or to use a real-world scenario, if you use any of the Google services, and say you log into Gmail, and now you're automatically logged into Drive and YouTube and any of the Google applications, they basically do the same thing. You go and log in at accounts.google.com. Once you're authenticated, a session cookie or a session ID gets created, stored in a cookie on that accounts domain. And then whenever you visit one of Google services, they silently go and check that account domain, see if there's a valid session ID, and then issue, if there is a valid session ID and the user should be logged in, they basically log you in for that ancillary Google service. So basically, you log in your authorization server. The server stores a cookie, and then it issues a JSON Web Token to your client application. And now, instead of storing this JSON Web Token in local storage or in session storage or in a cookie, you just store it in memory. Ideally, you wouldn't store it and you would go to the authorization server every time, but that's just not realistic. So you can store it in memory, where it's going to be much, much harder for a malicious script, an XSS vulnerability to get a hold of that token, because if that token is captured, is intercepted, anybody that can intercept the token can basically impersonate that user, and you don't want that to happen. So now you have that JSON Web Token in memory. You use it as long as that single page application session is active. The user can go and talk to your secure infrastructure, get tokens back, and get private data to the front end client, and basically request new resources. But what happens when the user inevitably refreshes the page or opens it up in a new tab? And the solution to that is basically, if the user is logged in the authorization server and they have a valid session cookie on your authorization server, not on your front-end client or your API, you make a silent authentication request. And typically, like the way we do this at Auth0 is we create a silent iframe, go to the authorization server and say, hey, is this user logged in at mytenant.auth0.com? And if they are logged in and if they have a valid session that we check in a stateful manner, then we issue you a new token. And you again store this token in memory, and then you use it to talk to your API services. And you can do this every time your Vue application is bootstrapped or your Angular application is bootstrapped because it was refreshed, or you're writing code and you just made a change and the CI process kicked in. The page was refreshed. Do the silent authentication. Go to the authorization server and get the new token. And now you can also see, putting this in a DevOps perspective, these three colors, these three shades, these all three of these services can easily be containerized, put up on Kubernetes, and evolve separately. So if you are building your own authorization server, you might start with just username and password authentication, but then down the line you might add single sign-on, you might add multi-factor authentication, anomaly detection, all that stuff. And you can evolve all of those features just in this orange area, and then allow your Angular or Vue application to, again, evolve independently from your backend API service or identity service. So everything is kind of microservice, containerized, and working in its own domain. So a couple of additional resources, if you guys are interested in learning about JSON Web Tokens, how they work, how to implement them in your infrastructure. JWT.io is a really great resource. You can learn about tokens. You can decode tokens there. So if you are working with tokens and you want to, and something's not right, you're not sure what's going on, you can paste the token in there, and it'll tell you, what's within the token's header and payload. You can verify it there if you have, if you're using a password or a public key. If you're curious about learning more about the JWT signing algorithms, I have this bit.ly right here that goes bit.ly JWT-ALG. So there you can learn why you should be using RS-256, the asymmetric signing algorithms, but you can learn more about all of the different ones, because HS and RS-256 are just two of the examples. And then finally, if you're curious about these slides, DevOps-JWT, you could download them. And then I also had a demo, but I don't have time to do the demo today. So I'll just summarize it with single-page applications. Single-page application security is mainly concerned with the authorization use case. You're never going to be able to have a lockdown, secure, private, single-page application that lives in the browser. That's just not a possibility, and probably for good reason. JSON Web Tokens, though, are excellent for securing SPA applications and taking care of that authorization use case. And then there are a lot of excellent HTTP libraries for any framework. So whether you're building a Vue application, a JavaScript application, a traditional web application that you're slowly migrating over, there's so many excellent libraries that work fully and interoperate fully with JSON Web Tokens that'll get you productive really quickly. And then finally, a security guard probably couldn't stop Thor from getting a beer, but your server can refuse requests without valid JSON Web Tokens and all of the correct payload data. And with that, thank you guys. If you have any questions, I know we'll have a few minutes for questions here, but if you have any questions or want to discuss more about JSON Web Tokens or web security in general, please follow me at Kukic on Twitter, and I'll be happy to get back to you. Thank you.